Okay, guys, we're going to, oh, look, I'm already doing that again. We're going to talk about rational functions, but first, I'm going to talk about rational numbers and just what rational means. Well, of course, the root word is ratio, and so if I write, say, 3/7, that is a rational number, and -5/9. If I write pi/4, that is not rational. Because the thing that makes something rational is that it can be written as an integer over an integer, with the bottom not being 0. So if I wrote pi/3 pi, that's rational because pi/3 pi is the same as a third. These are equal. So it can be written this way. But basically, when people started thinking about numbers, they started out with the numbers 1, 2, 3, 4, 5, 6, 7 because they were counting things. Then the next thing they wanted to be able to do actually probably is multiply, but at some point there was the idea of negative numbers. So like, I don't have a chicken and I owe my neighbor a chicken, so I have negative a chicken. And then there came 0 after that. So integers are kind of like the most basic required numbers that people would have come up with to begin with. So if it's a ratio of a very simple number to a very simple number, then we call it a rational number. And the reason you can't divide by 0, basically division when it first came about would have been, okay, so if I have 6 eggs, and let's say that in some weird world we're selling 5 eggs at a time, then you might ask, how many sets of 5 do I have? Well, I have 1 set of 5, and then I have 1 egg left over. If I have 75 eggs, how many sets of 5 do I have? And the answer is I have 15 of them. So that's what division answers. It answers the question, if I have the top number, how many of the bottom number do I have? So if I write something like 8/0, and I say, well, I have 8 chickens, how many sets of no chickens do I have? Well, then one of you might say, you don't have any. One of you might say you have 5. Somebody may say you have 1,000,000. You have infinitely many. There's no answer that makes sense because you can't count the number of no chickens that I have. So this one doesn't make sense. But it doesn't even make sense to do 0/0. This one feels a little more like it could be a thing. It kind of looks like it might be 1. It kind of looks like it might be 0 because it has 0 on the top. It still kind of feels like infinity because how many nothings do I have? Well, I don't know, go, count forever. You can count my nothings till the end of time. So this is called indeterminate form, so it feels more like it ought to be a thing, but it's still not. So we can't divide by 0, not even if 0 is on top. This is indeterminate, okay? So when we go to functions, the very basic functions that existed first were polynomials. Maybe first lines, and then maybe you wanted to calculate the area of something, so you ended up with squared, and then you wanted volume, so you ended up with cubed, and so forth. So polynomials are the very, very basic. So a rational number is an integer over an integer, very basic, where the bottom's not 0. A rational function is a polynomial over a polynomial when this guy's not 0. You still can't divide by 0. That's still not a thing. So what happens is, while in a polynomial you can plug in any x in the world that you want, a rational function you have to be careful. You can't plug in x's that make the denominator 0. So that's where you end up having domain concerns that you've not had before. You have domain concerns with, at this point in your mathematical career, square roots of things and ratios of things. And that's really basically it. So if I have the square root of something, the something has to be at least 0. And if I have something divided by something, the bottom something has to be not 0. That's pretty much it. That's and this, I guess, would be any nth root where n is even. Then you have this situation. And these are really the only domain questions you run into at this point in your career. Okay, so domain questions, I guess, we'll come up with later, because we're doing basically, I don't know where you are in this topic, so I think we're probably ending up with some Algebra 1 topics mixed in, but I guess we'll live. So we have first simplify. This is on Excel, obviously, and I'll leave these all. I'll link to all these. So simplify and write your answer using whole numbers and variables. This is not going to ask us about domain, but I'm still going to mention it kind of as we go. So we have 8v squared plus 9v over v. Now, one thing that I forgot to talk about, which is something that probably will seem quite familiar already, if you have something like 8 over 12, you might automatically say that's 2/3, or you might not. But if you factor these out, like we did before, so you would do 8, 2, and 4, 2 and 2, like that. And then 12, if you did that way, you'd get 2 times 6, which is 2 times 3. And because when you multiply fractions, you just multiply straight across, I can split this apart. It's 2 over 2, 2 over 2, 2 over 3. Well, this is 1, and this is 1. So that's why this just equals 2/3. But with numbers, you kind of have a sense about how they factor. With this one, maybe you don't, and maybe you do. But the thing we want to do is factor. We've just been working on factoring. So these have no number in common. If you factor out 8, you get 2, 2, 2. 9, you get 3, 3. These guys have nothing in common. But we do have one v. Remember, it's the smallest power that exists anywhere, so I have a v. And then 8v squared divided by v is 8v. 9v divided by v is 9. So I can rewrite this as v over v times 8v plus 9 over 1. And this is 1, but note, if v was 0, this would have been 0 over 0, and we cannot cancel out indeterminate crazy things that we don't know what they're equal to. So the only reason I'm able to forget this exists is if I assume that v is not 0. So at this moment in time, we're simplifying, and they're not asking you to note that, even though my OCD really, really, really wants us to have a spot to note this. But we have to assume v is not 0 to say these two things are equal. If v is 0, these things are not equal at all, because this would be 0 over 0, and this would be 9 if v was 0. So that's not equal. Okay, so anyway, right now what we have is 8v plus 9. Okay, 9z plus 7 over 9z squared plus 7z. I really ought to make these little pictures and post them in. That'd be smarter. Or not, it may take forever. Let's find out. Oh. Meh. I'll just keep doing what we're doing. 9z plus 7, 9z squared plus 7z. Okay, so I would factor first, factor everything really. 9 and 7 don't have anything in common. and the z only appears in the first term, so we definitely can't do anything with this. Down here, so this is still this. Down here, we have a z in both cases. So z, 9z squared divided by z, 7z divided by z. This time, I've got 1 over z, 9z plus 7 over 9z plus 7. So this is the thing that equals 1 if 9z plus 7 isn't 0, because if it is, then this is a determinant. So this can't be 0, which means 9z can't be negative 7. And there you see what z can't be, but also note this. This was in the bottom to start with, so was this. So z can also not be 0. If z is 0, these are both undefined. So this is still equal, but it doesn't make sense as an expression. So anyway, 1 over z k squared minus 8k over k And you might get where you want to be quick about it and you look at this and you think you already know, but be very careful, because when things aren't factored, people have a tendency to just mark out kind of willy-nilly. I can't tell you how many times I've seen people do this. That does not work, okay? If that worked, then what we would have is k minus 8k equal to this. So let's say k was 3. Then if I plug it into this one, I get 9 minus 24 over 3 equals minus 15 thirds is minus 5. And on this one, I would get 3 minus 8 times 3 is 3 minus 24 is negative 21. These are not equal, so clearly that's not a thing that's okay to do, but people do it all the time. So let's start again. So we have to factor, so the only way to cancel is to get things factored. So up here we would take out a k squared divided by k is k, 8k divided by k is 8, so that's k over k times k minus 8 over 1. So that's 1 if k isn't 0, and we get k minus 8. And we don't write the over 1. And it's okay if you want to just do this. That's what people end up doing eventually, but I want to kind of try to get through to you why it is it works so that you don't end up doing crazy things and canceling weird. So k minus 8. Oh goodness, n squared plus 10n plus 21 over n plus 3. Okay, 1, 10, 21, 1, 3. Okay, so the bottom part we're not going to be able to factor. The top part we will be able to factor. If we have 10 and square it, that's 25. So this is not a square. So we need to come over here and say, okay, 21. They're going to be both positive because this plus makes them have to match, and this plus makes them positive. So 1 and 21, 3 and 7, those are all the choices. These add up to 22, and these add up to 10. So we've got n plus 3, n plus 7. If that snagged you a little bit, then you need to go back to the factoring thing we just finished. Okay, so here's what we have. So this is n plus 3 over n plus 3 times n plus 7 over 1. This is 1 if n is not negative 3, leaving n plus 7. This one is almost just like something we've done before. If you factor w out of the bottom, you get w times w plus 10. So that one, I'm just trying to get a more interesting one. That's 1 over w, assuming w is not negative 10 or 0. If you factor m out of the bottom of that one, you get m times m plus 1. So the m plus 1's cancel, so it's 1 over m, assuming that m is not 0 or negative 1. Okay, that's more interesting. 16814. I don't remember what the variable was. Okay, so if I have 6, I get 3, I square it, I get 8. So that one is not a perfect square either. So 8, because this is positive, the signs will match. Because this is positive, they're both positive. So 1, 8, 2, 4. We're looking for 6. Okay, so this is m plus 2 over 1 times m plus 4 over m plus 4. If we agree that m is not negative 4, then that's m plus 2. Oh, I typed the wrong variable. N plus 2 would have been correct. So they're giving us a similar one, so we'll do this one and then we'll go on to the next thing. So 1, 9, 21, 4. Okay, so half of 9 is 4 1/2, which means this isn't going to be a square. So this would be non-integer. So 20. Again, this is positive, so they match, and this is positive, so they were both positive. We're looking for 9. Okay, hopefully at this point I can do this. Since we see we've got it written as a product, then when I come over here, I'd write s plus 4 over s plus 4 times s plus 5 over 1. So if s is not negative 4, this is equal to s plus 5. Okay, so now let's look at adding and subtracting. First of all, I actually did attempt to hit the correct button that time. I guess I just didn't press hard enough. Okay, so if I'm adding fractions, so let's say I'm doing 2/3 plus 1/5. I can't, basically the denominators make them like terms or not like terms, so I can add, for example, 2x and 3x and get 5x, but I can't add 2x squared and 3x and get 5x anything, right? This doesn't work because they're not like terms. Until these denominators match, they're not like terms. So if you imagine that, x's are like cows and x squareds are like cars, and that's why you can't add them. This one's a fifth, and this one's a third, and they're different objects, and so you can't. I have 2 of something, and you have 1 of something different. Mine's a third, and yours is a fifth. So we can't add them until we can kind of decide essentially how many cows is a car worth. So what we need to do is get a common denominator, and the common denominator is the least common multiple. So it's sort of like the opposite of what we just finished doing. So we have just been doing greatest common factors. And in this case, we want the opposite deal. If they don't have anything in common, you're going to have to multiply them. You know what? Let me pick something that does have something in common so that we can talk about that. Okay, so let's say that we have 1 15th plus 5/12ths, okay? So if I take 15 and 12 and factor them, 3 times 5, that part's done. 2 times 6, 2 times 3. So we have 3 times 5 and 2 times 2 times 3. So this is so far just like we did when we were looking for the greatest common factor. But this time, instead of looking for the thing they have in common, we're looking kind of for the things that they don't. Okay, so I'm going to need A3, and each of them has 1, so I need 1. I'm going to need a 5 because this one has a 5. I'm going to need a 2, and I'm going to need a 2. So essentially, instead of the smallest power that either one of them has of a value for the greatest common factor, I need the highest power that either one of them has. So this is my common denominator. So I would have 1 over 3 times 5, and I need times 2 times 2, so up here I do times 2 times 2. Over here I already have 2 times 2 times 3, so I need that 5. So I get 4 over 60 plus 25 over 60, 29 over 60. So let me see if I can make this a bit clearer, because I feel like that wasn't my best word right there. Let's say, let's say I wanted to add this. Okay, so 72 is 2 times 36. I'm going to branch a little this way because I know the other one's going to have to branch quite a bit as well. 36, you might go ahead and do 6 times 6 since it's a square and you're used to it. 2, 3, 2, 3. So we have 5 over 2 times 2 times 2. So 2 cubed, 3 squared. Okay, so now I'm just writing them as powers instead of listing them all out. It saves us space anyway. And then 180 is 2 times 90, if you want, which is 2 times 45, which is 5 times 9, which is 3 times 3. So that's 17 over 2 squared, 3 squared, 5. Okay, so I need, if I was doing the greatest common factor, I would say 2 squared, that's the smallest power of 2. 3 squared is the smallest power of 3. There's no 5 here, so I wouldn't put a 5. But I want to do the opposite thing. I want to take the biggest power. So I need to have 2 cubed, because that's the biggest power of 2. 3 squared, because that's the biggest power of 3. And 5, because that's the biggest power of 5. So that needs to be my common denominator. So 5 already has 2 cubed and 3 squared, so I need to multiply it by 5. The 17 has 2 squared, so I need another 2. It has the 3 squared and it has the 5. So this is 25 over, let's see, I guess 72 times 5, plus 34. So 69. And this actually can be simplified. This is 3 times 23 over 3 times 120. So 23 over 120 in the end. These couldn't be simplified before, but once I added them, they collapsed some things a little bit. So this is with numbers. But if I'd had the x's and the x squareds and the x cubed and the y cubed and whatever, it's all the same. I still need a common denominator. It still works the same way. So this 3 over wx plus 4 over wx, this one already has a common denominator. It's a like term. So I just have 7 of those things, whatever a 1 over wx is. Okay, this one does not have common denominator. I'm going to see if I can kind of work it in the box here. So because this is 10 over 1, the common denominator is easy because there's nothing there, so it's just tu. The highest power of anything is 1t and 1u. So I need over here tu, which means I have to multiply up here by tu. Once I've done that, I can just do the minus 5 right there, and that's done. Okay, so this one, 2 is prime, 3 is prime. So the highest power of 2 is 1. The highest power of 3 is 1. So I need to have, in both cases, a 6. So I have v over 2 plus, v cubed over 3. So I need them over 6. This one already has a 2, so I need to multiply times 3. And down here I need to multiply times 3. This already has the 3, so to make the 6 I need times 2. And so I have to do that on top also. At this point, I can just write this as 3v, this as 6, this as 2v cubed over 6. So okay, so st over 3 minus 6s plus 8. Okay, so with this, we've got the common denominator of 3 because this is just 1. So I need to multiply by 3 here, and I need to multiply by 3 up there. So I have 3 times 6s is 18s, and 3 times 8 is 24. So I have st minus all that over 3. So I have st minus 18s minus 24 because I'm distributing that. This one, everybody's going to need a 4. I'm going to skip a little bit here. So I've got 4 times c plus 4 times 9 minus c to the 5th d all over 4. So instead of c, I have 4c over 4, and instead of 9, I have 36 over 4. Same thing here, I need to multiply everything by 5. 3r plus 5s minus 5 over 5. Okay, let's look at this one, and then I'm going to go to this one. This was the Algebra 1 version. This will be the Algebra 2 version. That'll be better. And then I'm going to take a break and try to make my throat stop hurting. Okay. 9p minus p over 9p plus 4. I think that's what it was. Okay, so we need a common denominator, and this has a 1 right now. So 9p plus 4 is our common denominator. Okay, so we have that. So if I multiply the 9p through, I'm just distributing here, 81p squared plus 36p minus p that equals 81p squared plus 35p over 9p plus 4. I could factor out a p up here, but that's actually all I could factor out, so it's not going to get any nicer than it is. So 81, 35. Okay, so 3 plus, so that's 3 times d plus 1 over d plus 1 plus 5d over d plus 1. So that's 3d plus 3 plus 5d over d plus 1, so that's 8d plus 3 over 5 plus over d plus 1, and the top cannot be factored again, so we're back into that position of not being able to simplify. Okay, now let's look at these. 8. I'm not going to do a bajillion that look like that, but we can do one more, I guess. Okay, so here's what we have. So the top cannot be factored, and on the bottom we've got an extra g in both places. So these can cancel, and also be careful of this if you're just going to mark them out like that you don't say equals g, because g is still in the bottom, so you have to kind of imagine there's a 1 right there. Factor out the 7 on the top and you get y plus 7, so this is 7 over 1. Okay. 2d minus 18 over 34d. Okay, so you look at the top and you think there's nothing to factor out because it's a line. But in fact, there is something to factor out. There's a 2. And on the denominator here, you can just go ahead and factor out the 2. Or you could go factor 34. It might have other things. You don't really care though because the only thing you can cancel is a 2. So we can cancel that. And that's it. That's all we can do with that one. Don't get canceling those D's now. Okay, so this top part can't factor, so we're going to go for the bottom part there. This is positive, so the signs will match. This is positive, so they'll both be positive. We want 15, so there we go. And once again, don't forget this is really times a 1. Oh. Okay, sorry about that. Had to, well, locate my password. Okay, so s squared plus 3s over 25s. So we can take out an s up here. And we get s plus 3 over 25. This one is not interesting. We've done a million like that. Same. Okay, q plus 7, 111, 28. Okay, so we're going to factor that one, because that one's a line. Both will match, both will be positive. Love it when I multiply. Okay, we want 11. Okay, if you factor z out of the top, you get z plus 4, so this is just going to be z. Anytime you're not sure what's happening, pause the video and go try to work it and see if you can. And if you can't, go back and watch the previous one, and then try again. Okay, 1845. I don't remember the variables, so. Okay, so we're going to factor the one on top. Positive, positive. So we get x plus 3, or h plus 3 in this case. Okay, I'm going to do a few of these. I know I said I was going to stop after the last one, and I'm really tired and my throat really hurts, but I want to get through these kind of basic parts, and then the next bit will be, well, basic may be the wrong word, but the more introductory pieces, so that when we get to rational equations and rational functions, you know, that's kind of, those are bigger chunks. So those deserve their own video between the two of them. Okay, so we have 5 over 7r divided by r minus 2. Now, remember when you divide by a fraction, or divide a fraction, you do what's invert and multiply. So if I multiply a over b times m over n, I get a times m over b times n. This is sort of like the dream, right? This is exactly what you'd hope would happen. A over b divided by m over n is a over b times, and then you flip it upside down, n over n. So a times n over b times m. And some people do it, if it's written this way, some people just do this, and it ends up the same, okay? But you're inverting and multiplying is what you're doing. So if I'm going to do this, I need to make this be a fraction. If it's not a fraction already, I'm going to put it over 1. So 5 over 7r times 1 over r minus 2. So this flips. So I have 5 over 7r times r minus 2. I'm not going to multiply that through this moment because I'd like to see if anything will cancel. In this case, it won't. All I have is a 5 on the top, and none of this is a 5. So this is going to be 5 over 7r squared minus 14. That's distributing. Oh, it didn't count that attempt. It's been open too long. K over k minus 3 times 4. Because that would just be like 4 over 1, we just multiply the 4 through the top. And the bottom stays the same, because it'd be times 1. And also, incidentally, when you're dividing by something like this, because you're always going to multiply by 1 over it, what's going to happen every time, if it's a whole thing and not a fraction, is that it gets multiplied to the bottom. So let's see, 4k minus 3, 3k minus 1, 4 minus 3, 3 minus 1 minus 5. Minus 3. Okay, I think this is what was written there. So 4k minus 3 is going to be over 3k minus 1 times k minus 5, if I wrote this all down right, because this is going to be times 1 over it. It's divided by it over 1. That will always happen. If you're dividing by a whole thing, it goes to the bottom. I'm foiling now. Four minus 3, 3 minus 6. So the top stayed the same because it was times 1. And down here we have 3k squared minus 16k plus 5. I'm wondering if this is ever going to get to something different, where we have things to simplify. Although I'm starting to not make quite as much sense as I hopefully normally do, so it might be better to do the rest later anyway. But this one, because it's divided by 2, that's 2 over 1, so it's multiplied by 1 over 2, so the top stays the same and the bottom gets multiplied by 2 only. Yeah. I think I may have to, well, I mean this one, so it's times r, 5r squared plus 4r, so I'm just distributing the r through there. 21r minus 7. Okay, good, finally. Although I think this one may be worth doing the future. Okay. So this then is 4c plus 1 over 2c plus 3 times 1 over, because this didn't have a fraction, so it's over 1, 6c squared minus 7c plus 2. Now, we want to know if this factors, surely, because we're trying to write things as a product so we can cancel things. But this one isn't our nice one with the 1 over there. This one has a 6. So we have to do 6 times 2, 12, positive, so they'll match. This is negative, so they'll be negative. We want a negative 7, so we want this. So we have 4c plus 1 over 2c plus 3 times 1 over 6c squared minus 3c minus 4c, because remember we're just replacing this, plus 2. So I've got 3c in common on the first part. 6c squared divided by 3c is 2c. 3c divided by 3c is 1. And remember, if it's negative there, I always have to pull that minus out. So minus 2 It's interesting to me that nothing canceled, but it didn't. So, anyway, if something had canceled, like if this had been on top and also on bottom, and something would have canceled, then we'd have a cleaner thing to write on the bottom. As it turns out, we'd have to multiply out this whole mess to put the answer in there. And also, I am aware that this, I'm not doing my best work here. So, I'm going to keep working on this. Maybe this evening, but maybe not. I'll give you some practice problems, and maybe this part you actually already knew from last year, or maybe you didn't, but between now and Wednesday night. I'm hoping to get everything posted for you so that we can get this thing wrapped up. Maybe I'm spending too long on this because maybe some of this was Algebra 1 stuff, but the more preparation the better, I suppose. And of course you can always go to SalCon for these things. I will see if I can find an assignment already written by Ms. Hirsch for this and give you that as an option, and then you can either take that one or you can take, if that doesn't go well, then later you can take one that I create. So be on the lookout and just see what gets posted, and I'll send you a message.